6.1, verifying identities. Verifying identities is proof. Now we've seen some examples of it when we were doing the double angles and the sum difference angles, but these are, I think, probably one of the hardest things we're going to have to do for the remainder of the semester. We're going to be relying heavily on the bag of tricks. Now in the bag of tricks are the fundamental identities. There are 11. So when you go to start practicing these, you need to have those bag of tricks printed out in front of you. I mentioned it a couple times. You need to print it, have it ready available to you, and then you can use it whenever you need to. It is loaded on course docs. So to do these verifying identities, strategies. Now the problem with strategies is they are not the process. They are not the way it's going to always work. They are suggestions, and that is all they are. So more complicated side should convert to the other. It's usually pretty obvious who is more complicated than another. Fundamental identities, and you should rewrite them as sine and cosine almost exclusively, because I can give you credit if you rewrite to sine and cosine even if you can't get any further. And the trickiest part of it is we have to, when we are adding or subtracting fractions, we have to have least common denominators or at least common denominators. And keep in mind, these are not numbers this time, these are all trig words and trig concepts and trig relationships. So we're going to start out with real basic ones. These three along the side, example 1, 2, and 3, are going to be using the fundamental identities, the things from the bag of tricks, pretty much exclusively. So for the first one, it says verify. Cosecant tan x equals secant x. When you are tasked with verifying, and that is the direction, you can only work with one side and one side only. You cannot make the second side equal the first side. You work with one whole side, and it has to match finally to the other side. So cosecant, according to the bag of tricks, is 1 over sine x. When they are touching each other, it is multiplication. Tangent, according to the bag of tricks, is sine over cosine. So now when we look at this, we can cross off sine x and sine x, and we get 1 over cos x. And then we go back to the bag of tricks again, and 1 over cosine x turns into secant x. So we cross these signs, and we get 1 over cos x equals secant x equals secant x. Check mark, done. Very easy, you're not going to have many of those. But the idea is to know those fundamental identities, how to manipulate them. Second verify says we have tan of theta times cotangent of theta over cosecant theta. So this time I decided not to go to sine and cosine. I could have, would have been perfectly fine. There are multiple ways to do all these problems. So we are going to keep it because tan and cotangent are reciprocal identities to each other. So I'm going to keep tangent theta written over 1. There's that placeholder we talk about. Times cotangent is 1 over tan. And then I actually forgot a piece in here when I was writing this. This is cosecant theta on the bottom. So then tan theta over 1 times 1 over tan theta goes to 1. The cosecant theta still comes down. So we have 1 over cosecant theta on the next line, but then we go back to the bag of tricks again, and 1 over cosecant is sine, which equals the sine that we were asked to find. These are like puzzles. One of the only really good things I can think about this is you know what the answer is before you start, because the one side is what you have to get to. You're not solving for an answer, you are matching an answer. So example number 3, we need to verify this. Now this is also saying fundamental identities again. But we're not going to start with fundamental identities, it's going to happen inside. So this is a parenthesis situation, so this is order of operations, PEMDAS. So sine squared times 1 is sine squared, and we are keeping this cotangent squared theta. Once again, we're going to the bag of tricks, cosine squared over sine squared. So as long as the numbers in front, or in this case the exponents match, we can write them as they are. So when we distribute, sine squared times 1 is sine squared, and sine squared times this, the sine squareds disappear, so we bring down just a cosecant squared. Once again, back to the bag of tricks, have to know the bag of tricks manipulations and memorizations. Sine squared plus cosine squared is that most important one, and it is 1. 1 equals 1. Perfect matched up. Very heavy on fundamental identities, not so much the algebra. When we move over to this side, we're going to start winding up with more algebra ideas. So right here it says manipulation. So we are going to look at our bag of tricks, and under the manipulations there are 2 pieces. So sine squared is under the manipulations, and where sine squared is, that is equal to 1 minus cosine squared. As we have talked about throughout the entire semester, when you substitute in for something, it has to go inside of parentheses, no matter what. So this cosine squared x is the one from here. Minus is from the formula. Parenthesis, 1 minus cosine squared x. Then this becomes negative distribution, just like it always has. A negative followed by parentheses is negative distribution throughout the parentheses. So you get cosine squared x. This becomes negative 1, and this becomes plus cosine squared x. Well, when we look at this, these cosine squared x's can't disappear this time because they are both positive. So we have one cosine squared x, and we have a second cosine squared x. So technically we have 2 cosine squared x, and then minus 1, which matches this side, 2 cosine squared x minus 1. Example 5 is another move, but this time our move starts with GCF, very old-fashioned rule. And we are looking at what we have here. So on this left side, which obviously looks more difficult than the right side, we have a sine x single piece, and then we have a sine x attached to the cosine squared. So my GCF is sine x. So I'm going to pull sine x out, parentheses, that's 1. Remember, GCF means you're dividing away, minus that sine x out gives me cosine squared x. You can always check yourself by ghost distributing. Sine times 1 is sine times negative cos squared is sine x cosine squared. But we are continuing on from this pink line right here. Sine x comes down, and then we bounce back into another bag of tricks and another manipulation. We have discovered that 1 minus cosine squared x is sine squared x. So we replace this with sine squared x. We had a sine x outside, now it becomes basic algebra again. Sine times sine squared is sine cubed x, which is our match from the other side. So this one did not do much trig work with it. It did a GCF, and then it had the one manipulation, and then went back to algebra, which is another situation. Example 6. They're getting a little more difficult. On this side it says cosecant theta minus sine theta equals cotangent theta cosine theta. So now we have to work with this and create these into their reciprocals. So cosecant becomes 1 over sine minus sine over 1. Well, we need to get a common denominator. It was up here under our least common denominator rules as a strategy. So we want to have sine as our common bottom. Well, this one already had sine, so this stays 1 over sine minus. In order to put a sine theta here in this bottom, we need to put another sine in the top, so sine times sine becomes sine squared theta. We need to put these two things together, combining our common denominators together. A little while ago we did something where we split them apart, now we're putting them together, which is technically more common to what you're used to. 1 minus sine squared is the top over sine. Bottom remains sine. Well, 1 minus sine squared has to come from the bag of tricks. Bag of tricks means manipulations. So we're going to find 1 minus sine squared and discover that that is cosine squared theta on top, sine theta on bottom. And you'll be like, there is nothing I can do with that. Well, technically there is nothing trigonometry you can do that way, but there's a whole bunch of algebra you can. So cosine squared theta means you're going to break this up, because when things are multiplied together, they can also be separated. So cosine is going to take a cosine over sine times cosine over 1. And you may say, why did I not have a sine on this one? Because there's only a single sine down below. So you take the cosine, put 1 on each numerator, and then you take the sine and put it on one of the denominators, and then you're stuck with 1 on the other. So once the split is done, back to trig we go. Cos over sine is cotangent times cos over 1 is cosine. I am now going to switch us to our next video. So it will be a moment or two, and I will start and do 2 more, I believe, identities.